So we're back and we're finally ready to start calculating some flow rates. So we need to do that by defining a function, and we're going to call that q20, and it's going to take some internal p as its input. Oops. And what we need to do first is we need to take all of the variables we have up here that we need and define them globally because they're outside of the scope of this cell because they're going to be used inside the function here. So global heads, we need the net Q, we need the flows, we need P. That's it. Next thing we need to do is we need to set this P in from internal indices into the internal P because before it was just P guess, but now we need to set that to actual internal P. So P at internal indices equals internal P. Nope, just internal P. Next thing we do is calculate the heads. So, and the head of a liquid is, remember, P divided by rho divided by G plus Z. Cool thing here is that these are all now arrays or matrices or whatever you want to call them instead of just numbers. So the next thing you want to do is you want to hit all of these pipes at once and not just, calculate them by hand individually. So we're going to have a for loop. So for I in range of n pipes. What we're going to do, well, we're first going to calculate the delta head. Delta head is equal to, that's the heads. And first we're going to have them be from the 2 node. And that's going to be indexed at I. And then we're then going to subtract it from the heads from the from node. So heads, head from node I. Next thing we're going to do is calculate the flows. That's flows at I. And that's going to be equal to, using the flow function from earlier, the delta head. Delta head lengths. And that's going to be at I. The K, which is also going to be at I. The diameter at I. And finally, the ED pipes, so it's pipes ED, that's also at I. So next thing we want to do, now after we have this, we have all the flows. So if we look at the actual geometry of the problem, we see that pipe 1 has two outputs and pipe 2 has 2 inputs. So what this translates to is right now our variable, these net flows aren't quite equal to 0 because there's 2 outputs and there's 2 inputs. So we need to do some adding in our code here. So we're going to come down here, and next thing we're going to do is we're going to add our net Q. We're going to first fill this with zeros, and then the next thing we do is we need to actually account for the 2 out of the 1s and 2 in for 2, and we're going to use the np.add at, and this is going to be in the net Q in the 2 node, and it's values in the flows. And then we want to do it again for the from node, so np dot add at. And that's going to be netQ. From node. And that's going to be negative flows in this case. And finally, we're going to want to return the netQ. And this is going to be at internal indices. Internal indices. CIE. Internal indices. There we go. Yeah. Cool. Now, the last thing we need to do here is we need to actually use a root solver to find everything, because before we're just turning in some internal p's, but we don't actually know what the root solving finder is. So what this is, we're going to have a result, and that's going to be equal to the root function at q to 0. That's the function we're going to solve the root for of this vector, and our starting guess is going to be internal p guess. Ooh, hello. Name head is not defined. Ah, heads. And also from node is not defined because I can't spell. Wow. That's it. Now, the last thing we need to do is print these out in a readable format. So, and then we can actually see what the flows are. So we're going to have I in range from, we're going to have this going to be in the number of nodes, so in nodes. And finally, we're going to print this is all formatting stuff. netQ, use the variable I here. Ooh, no, it needs to be the, so it reads it as the variable. And this is going to be netQ I and colon 9.5 F, just to get the spacing right. And P, and that's going to be we're going to use I again, and colon 9F. Finally, one of these boys to close it all off. Ooh, there's something wrong with my thing. Aha, yes, I did not use the wrong bracket here. There we go. That makes it all better. And next, finally, that was printing the net flows saying they're all 0, and now we're going to print the actual flow rates. And so for I in range of n pipes, this is going to be largely the same as before. So print f from node I, close curly bracket, close curly bracket, to node. We're going to index this again, saying this is going to be I. These are all variables, close that off, space, Next is the flows that we need. Flows 9.5 F meters cube per second. Cool. So that should print everything off. I'm gonna go look through this, make sure everything works, and then come back, and then we're gonna read this off. Cool. So we're back, and we're here to see if this works. So we want to first calculate everything here. So in this, make sure that we have our Q to 0 internal P run, and then we need to have our root solver so we can actually have our net flows be 0 and through the middle nodes. And finally, we print out everything. Cool, yeah. So this is what we expected. We see here we have a net 0 or about 0 for everything. And then we have our pressures given here. And then we have our external nodes be 0 because that's what the problem statement said. And here, these are our net flows through 0 to 1, 0 to 2, and these. And the only differences we see here are because 5 times 10 to the negative 4 and 2.5 times 10 to the negative 4. These differences are due to the fact that we have different initial guesses. If we go up here and say have 10 be our initial guess, and then run this again, see that changes it a little bit. Our net flows are still almost 0, and our pressures change, but that's just due to the root finding and the error from that. But other than that, this is a complete code. So that's it. Thanks for watching.